Glenn Acaster, I'm a network architect at Node 4, and today I'm going to be talking to you about SD-WAN versus MPLS and some of the key considerations for your business. Before we start, I'd like you to consider any time where you've had performance degradation or bandwidth exhaustion on your network and how that has impacted your business, and whether a smarter network with better bandwidth utilization could actually alleviate those issues. So to start, MPLS, or Multiprotocol label switching, is a long-standing service provider technology where we can connect private sites, branch sites, data centers, or public cloud into a private network. As you can see from the diagram, that all comes into a private cloud, effectively, a private network, and then typically you would break everything out through that data center. You've got your internet and your software as a service public cloud platforms also going through that central data center as well. There's a couple of advantages to this method. So the first one being it's private network, it's static, and it's very robust. As I mentioned, it's a long-standing service provider technology. It's reliable. You've got typically service assurance behind it. You've got service level agreements. You've got somewhere to turn if things go wrong. You've got that provider that manages the solution end to end, and it's a complete private network. Also, you get things like quality of service, which is important for things like business applications. If you want to prioritize or allocate bandwidth to those applications, then you can do that quite easily with MPLS. There's a few disadvantages though. The main one being, or one of the main ones, is that it's primarily active-passive connectivity. So normally you'll have a primary circuit where all your traffic will go, and then you have a secondary circuit which will only be used in the instance that that primary circuit has failed. And that is usually a hard up or a hard down situation. So the primary circuit has physically gone down. It does not usually consider service degradation. You've also got inefficient routing to the cloud and software as a service platforms. So as I mentioned earlier, everything typically has to go through that central data center, that central internet breakout, and that central firewall, which means you need quite a high performance internet breakout and firewall to actually accommodate for that. Also, you've got unrestricted communication between all of the sites on the MPLS usually, which is great if you've got different sites and everyone needs to talk to each other between their computers, file servers, things like that. But it also means that if you were to get a compromise on one of those sites, that could quite easily spread across all of those sites as well. So what's the alternative? So a relatively new technology is SD-WAN, software-defined WAN. As you can see here, slightly different topology. We've moved from private connectivity in this instance to internet connectivity. And what you've got there is you've got the ability to break things out to software as a service platforms and public cloud directly through that internet connection. And you've also got an IPsec VPN or multiple IPsec VPNs to get back to those central data center locations. Obviously, there's some advantages to this. Typically, you would deploy SD-WAN appliances on site, and they would be centrally managed, and you can build policy-driven networking. So there'll be things like site-based profiles. Maybe you've got small, medium, and large branches, for example. And you can configure those in the same way to get consistent configuration across your entire WAN. You've got dynamic availability and performance monitoring. So we're now not just checking whether a circuit is available, we're checking whether it's performing to the metrics that you specify. And that could be things like latency, jitter, and packet loss. If any of those metrics were not to be met, then you could take that circuit out of service and you could fail over to another circuit, not just checking whether the circuit is up or down. You've also got built-in security, which, as I mentioned earlier, is key, and that's internal and external security. You have the ability to do internal segmentation, but also you protect against internal threats because you now have internet breakout at every branch. And you can do fast deployment. You can potentially ship these devices to site with no configuration on them and do zero-touch provisioning so that they retrieve their configuration from the centralized management platform I mentioned earlier. It does have some disadvantages. You've now got the many internet access points, as I mentioned a couple of times. You do need to secure that, and it is really important that you take a lot of consideration into that. And you may require some development to fully harness the capabilities of the platform. It is automated, it is dynamic, and you need to be able to control that. As you can see, cost is not on there because in a comparable connectivity scenario, it doesn't save you as much cost as is often advertised. So why not have both? Node 4's approach to this problem is to usually do a hybrid WAN solution. So we can offer you MPLS and direct internet connectivity and overlay that with software-defined WAN. That gives you the performance benefit for critical and data center applications of using the MPLS, but also you can send your public cloud and SaaS traffic directly out to the internet. You still have the option for failover because you can build those VPN tunnels back to the data center of the internet connection if your MPLS circuit were to fail. And you can also break out your internet connectivity through the MPLS and centralized breakout, as you did before with MPLS, if the internet connection were to fail. You can still benefit from having a managed service provider. You can still get that one place to turn if there are problems. And you can rely on them to build your resilient network with a multi-carrier strategic approach, so that if there is a major failure with one of the carriers, it doesn't affect your entire network in one go. MPLS is still relevant. There's definitely going to be businesses out there that are always going to rely on this robust and reliable MPLS technology. So we wouldn't position this in every scenario, but we would definitely like to talk about the disadvantages and advantages and where this can be put in place to meet business requirements. You also have the option to future-proof your network. So you can put these appliances on site now, and you can turn on the features in the future when you need to.